Hello friends, welcome to Learner's Planet and also welcome to this second session of types of number. Friends, in our previous sessions, we have discussed about natural numbers, whole numbers, integers, rational numbers and irrational numbers. In this session, we are going to discuss about real numbers and complex number. Now let's begin today's journey. So here we see real numbers. The complete set of rational and irrational number is the set of real numbers and it is denoted by R. That means R is combination of rational and irrational numbers. And we have already discussed about natural numbers, whole numbers and integers, and these three are actually subset of rational numbers. So these three are already part of rational numbers, so all of these are also considered the elements, all of these are also considered as the part of or set of real numbers. Okay friends, now real numbers are the numbers that which can be represented as a point of a line. All the real numbers follow the order property. That means there are no two equal real numbers. One of them must be greater and other of them must be less than the other previous one. So if there are two numbers, maybe A and B, so either A will be less than B or A will be greater than B. So doesn't matter whether it is a decimal number or it's a fraction, it's a third or whatever the number is, but two distinct number cannot be equal. Now we see a number line over here. All the, as we have already discussed, all the real numbers can be represented by the number line. We see the a number line over here. It's an element 0, and over the right side of 0 there are positive number, and on the left side of 0 there are negative numbers. So 1, 2, 3, these are positive integers. Negative 1, negative 2, negative 3 are all of these are negative integer, and 0 is a non-positive, non-negative integers. So we have to be very careful. If we are talking about positive numbers, maybe they are integers, maybe they are real numbers. We have to arrange them on the right hand side of 0, and if the numbers are negative or negative real numbers or integers, we have to arrange them and at the left side of 0. Okay friends? Also, every real number is represented by only one point, and for every point there is a real number. Okay friends, so and of the two numbers, the number on the right hand side is always greater. So I hope you must be clear about the real numbers. Now friends, let's see some important points which we have to keep in our mind. All the integers are rational numbers, but converse need not be true. Suppose I take an example, say 2, 3, 4, 5, or maybe negative numbers, say -10, -11, and so on. So all of these are integers and these are rational numbers also. But we have some rational numbers and good amount of rational numbers which are not integers. Say I can say 2 by 3, 4 by 5, or maybe negative 2 by 3. So all of these are rational numbers, but these are not integers. So all the integers are rational numbers, but the vice versa is not true. Similarly, negative of an irrational number is an irrational number. Suppose I have a number √2. It's an irrational number. It's negative, that is -√2. That will also be an irrational number. Now sum of a rational number and an irrational number is always an irrational number. This is a rational number, this is an irrational number, and the sum is, that is 2 plus √3 is an irrational number. Now the product of a non-zero rational number and an irrational number will always be an irrational number. Suppose I have a number that is rational, that is 2, and an irrational number that is √3. So their product, that is 2 √3, will always be an irrational number. Similarly, if there is an element that belongs to rational number and there is an element that doesn't belong to rational number, then AB is rational number. That means their product will be a rational number only if A is 0. That means the rational number which we are talking about here is 0. Okay, so 0 into any irrational number, that is root 3, will be 0, and this 0 is a rational number. Okay friends. Now let's see the next point. Sum, difference, product and quotient of two irrational number need not be an irrational number. It may be a rational number also. Now let's see how it is possible. Suppose I have an irrational number, that is 3 plus root 2, and I have one more irrational number, that is 3 minus root 2. Now suppose I am going to add them. What I'll be getting is root 2 and root 2 will be cancelled, and what I'll be getting is the sum as 6, which is a rational number. So the sum of two irrational number can be a rational number. Similarly, in the same case, if we are going to multiply them, that is 3 plus root 2 into 3 minus root 2, that will give, it's 9 minus 2, that is 7. So further it is a rational numbers. That means product of two irrational number can be rational also. Similarly, quotient, suppose I have a number say root 3, 2 root 3 and divide by maybe 5 root 3. So the quotient may also be a rational number. Similarly, difference, suppose I have a number minus 3 plus root 2 and the other number is maybe 3 minus 3 plus root 2. Suppose I subtract this number from this numbers, then root 2 will be cancelled, and what I'll be getting is 3 plus root 2 plus 3 minus root 2. So what I'll be getting is 6. So which is a rational number. So sum, difference, product and quotient of two irrational numbers need not be an irrational number. It may be rational also, and it is also not necessary that for every time they will be rational. For that also we can take some examples. Suppose I take a number that is 2 plus root 3 and I take other number that is maybe root 3 plus root 7. This is also irrational number, this is also an irrational number. Now their sum, their difference, their product and their quotient, none of them will be a rational number. So we have seen both the cases. Maybe in one case sum, difference, product and quotient of two irrational number can be rational or it can be irrational also. Okay friends. Now let's have a recap of all the properties of irrational numbers once again. If A is irrational, that means if any number A is irrational, then its negative will also be irrational. The sum of a rational number and an irrational number is always irrational. The product of a rational number, that is not equal to 0, and an irrational number is always irrational. That means the product of a non-zero rational number and irrational number is always irrational. The sum of two irrational number is not always an irrational number. The product of two irrational number is not always an irrational numbers. We have discussed the points with examples also. Now the next important point is if A and B are rational, suppose we are having two rational numbers and their product, that is AB, is not a perfect square, then root AB lies between these two numbers, that is root AB lies between A and B. A quick recap of real numbers. The collection of all rational and irrational numbers denoted by R, and it is called the set of real numbers. The notation X belongs to R means X is a real number. This sign is the sign of belongs to, that means X belongs to the set of R, where X is an element and R is the set of real number, and this element X belongs to the set of real numbers. Friends, we see a chart over here. Let's understand this chart for better clarity of all the concepts of numbers. It is a set of, that is, the master set is real numbers. This set, there are two breakups of the set, that is rational numbers and irrational numbers. Rational numbers further divided into integers and non-integers, and integers are divided into negative integers, zero and natural numbers. Similarly, non-integers are divided in negative and positive integers. Similarly, irrational numbers are negative and positive. So from this chart, we can conclude that real numbers are the master set and all rational numbers and irrational numbers are proper subset of real numbers. Friends, till now we have seen the numbers like natural numbers, whole numbers, integers, rational numbers, irrational numbers and real numbers. All the numbers are real numbers. If it is true, then what is a complex number? Every number which exists in universe is a real number. Then what is a complex number? Friends, some numbers are there which exist, but which exist only in your imagination. That these numbers are known as complex number. Now, what type of numbers are there which exist only in imagination? Let's see. Suppose I am having a number 2. 2 into 2 gives 4. Minus 2 into minus 2 gives 4. In both the cases, we are multiplying two same numbers and we are getting one number. Even in this case, I am multiplying two same numbers and getting one number. Now, if I wish to find the square root of number 4, I'll be getting either 2 or minus 2. That is, square root of 4 will be 2 or minus 2. Now, what will be the square root of minus 4? Can I have two numbers? When they are multiplied, I'll be getting minus 4, but the numbers should be same. I don't have. So these sort of numbers, that means the negatives of square roots of negatives are actually imaginary number. They really do not exist. They exist only in imagination. That's why these are known as imaginary numbers. So root of minus 4 will be an imaginary numbers because there does not exist any number which is multiplied by itself and produce minus 4. Here we introduce a term that is I, or in other words we can say it is iota. Iota is actually root of minus 1. Okay, and this is and it is a symbol of an imaginary number. And a combination of a real number and imaginary number is called a complex number. Here A is a real number, that is real part, and B is the part that is imaginary part, and I is, that is iota over here. So A plus IB, that is real plus imaginary, is a complex number. Okay friends, now let's move on. I hope you must be cleared about all types of numbers. Now in the next session, we will be seeing some more properties of the numbers, some more important points about numbers. All the best, and we'll be continuing our journey of number system.